Hi everyone. In this video, we'll go through a topic on linear inequalities. Linear inequalities. We know what equations are, right? Equations are an expression with equal to sign, right? So you have an expression on the left hand side, you have an expression or a number in the right hand side, and then you have equal to sign. So you have left hand side and you have right hand side and you have equal to sign. So this is an equation. What is an inequation or what is an inequality? We have comparison symbols like less than, greater than, less than equal to, greater than equal to. So expression with these comparison symbols such as less than, greater than, or less than equal to, greater than equal to are called as inequations or inequality. So these symbols are inequality symbols. Now when these symbols are put in equations, it becomes an inequation. Numerical inequalities. So if you have numbers on both the sides, on the left hand side, we know, right, this is left hand side, this is right hand side, and here you have equal to sign. So if you have numbers on both the sides, then it is called as numerical inequalities. Literal inequalities. Literal means character or letter. So if you have letters on one or both the sides, then it is called as literal inequalities. For example, you have x greater than 5 and y greater than 6. Double inequalities. You have an expression such that you have two inequality symbols. Here there is one inequality, here there is one inequality. Similarly here. So these are double inequalities. Strict inequalities. Strict means you just have less than or greater than. If you have equal to, say 3 less than or equal to, or greater than or equal to, if you have equal to along with less than or greater than, then it becomes slack inequalities. What are strict inequalities? It's a perfect inequality. One is less than the other. One is greater than the other. In slack, one could be equal to the other or less than. Similarly, one could be greater than the other and all or could be equal. Inequalities in one variable. So if you have an expression with only one variable, such as x, y, or z, but only one variable is nothing but an unknown, right? For which we don't know the value. So if there's one variable in an expression, then it's called as inequalities in one variable. If you have two variables like this, 3x plus 5y less than 10, then it is inequalities in two variables. Quadratic inequalities. Quadratic equation means it's of the form ax square plus bx plus c. So the x starts with power 2, then power 1, then there is no x at all. So this decreasing order of the powers of x forms quadratic equation. And when you have less than or greater than symbol in this particular equation, it becomes quadratic inequalities. So example this one, x square plus 4x plus 4 greater than equal to 0. Here are a few rules that we'll have to remember. When you have, similar to theory of equations, it's exactly like that. When you add a number on one side of the expression, you should also add the same number in the other side of the expression. When you subtract on one side, you should subtract on the other side. Similarly with multiplication and division, if you multiply on one side, you should multiply on the other side also with the same number. Same case with division. This is positive number. But in case you are doing it with negative numbers like this, you are multiplying with minus 3 on both the sides, the signs will swap. It will reverse. If it was less than, then it will become greater than. If it was greater than, it will become less than. So whenever you multiply or divide with a negative number, the signs will reverse. Also, I can say x is greater than 1. If I have to tell the reverse, if I reverse the expressions from one side and put it to the other side, right, then also the signs will reverse. If x greater than 1 means 1 less than x. These are few key notations that we'll have to remember, because this entire chapter is about finding the solution sets and showing it graphically. So when you draw the graph, these are the important symbols that we'll have to remember. This empty circle denotes excludes. This shaded circle denotes includes. This is infinity symbol. When you have two brackets, it is called as both sides excludes. When you have two square brackets, it includes. You can write brackets in a combination. If you have one with a curved bracket and the other with a square bracket, then it's called as left side excludes and right side includes, and reverse. In this case, it's left side includes and right side excludes. This is very important, right? We'll have to remember these notations. When we plot the graph and when we put the solution set, it's important to put these notations. When we solve the problems, we'll go through each of this in detail. So now you have an expression like this, 5x minus 3 less than 2. Now, what do you mean by a solution set? Solution set is the set comprising of all the values of x, right? of this particular expression. In this particular expression or in this inequation, all the values of x that satisfy this inequality forms the solution set. Now, what I will do is I have to find the value of x. So I'll shift all the other values to the other side. So minus 3 I'm shifting to the other side, so it will become plus 3. So it will become 5x less than 5. Let's keep the symbol as is. Now I shift 5 to the other side. So it's 5 into x, it will become 5 divided by 5. Thereby, this will become 1. So it will be x less than 1. X less than 1 means in the number line, you have 1 here, less than 1. All the numbers on the left side that is less than 1 would form the solution set. So if I say what is the solution set for this expression, then it will be less than 1 means 0, 0. Then it can be minus 1, it can be minus 2, it can be minus 3, it can go till minus infinity, right? So all these values satisfy this inequality expression. So this is the solution set. Now let's talk about the concept of excludes and includes. Now here it is less than 1. Less than 1 means, is 1 included? No, 1 is not included. Any number less than 1. That's why this is excluded. 1 should be excluded. So 1 is not there in the solution set. Now we'll take the same example here. Suppose it was like this, greater than 2. Instead of less than, I'm taking greater than. In that case also I'll get same value of x, but it will be with greater than symbol, x greater than 1. Now what will be the solution set when x is greater than 1? Solution set would be x greater than 1. So it will be 2, 3, 4, 5. It can go till infinity. But 1 is not included. 1 has to be excluded because it's greater than 1, not equal to, it's greater than. Now same expression, I'm modifying it. I'll make it as less than or equal to. When I say less than or equal to, here also I will get the same value. I'll get less than or equal to 1. Now what will be the solution set? It will include 1 now. 1 will be included. So whenever there is equal to sign, that particular number needs to be included in the solution set. So less than or equal to 1 means, so it will be 1, 0, minus 1, minus 2, minus 3 till minus infinity. Right? This is a solution set. 1 is included. If it was x greater than or equal to 1, then solution set will be 1, 2, 3, 4 till infinity. So this is the difference when we have equal to also along with greater than symbol or less than symbol. You need to include this particular number. So now we know the concept of include and exclude. We just have to denote it when we plot the graph. Let's look at few examples. Now, in this example, we have to find the solution set for this particular inequation. And always observe this. They would have told that x belongs to integers or x belongs to real numbers. R denotes real. Z or I denotes integer. Z or I denotes integer. Integer means it's a complete number, right? It doesn't have decimals or fraction. Numbers like 1, 2, 3, complete number. We'll take this expression. So when you calculate, you'll get x less than 2. Now, when I put the solution set, I will put all the numbers less than 2. Numbers less than 2 are 1, 0, minus 1, minus 2. It goes on till minus infinity. That is, there is no end to it. It's unlimited. You can have unlimited numbers. So this is how we denote. Now, same problem if I say x belongs to real numbers. Real numbers means it will have decimals, fractions, rational numbers, irrational numbers. So all that entire set of numbers form real numbers. In this case, again, the value of x will remain the same. Value of x is not going to change. But the way we represent the solution set will change. Here we will write like this. You put the brackets and then you put the range. So here you put the range in this case. Whenever you have real numbers, you put the range. You don't have to put every number like this as a sequence or as a series. You put a range from 2, minus infinity to 2, right? X less than 2 means minus infinity till 2. So it's minus infinity, comma 2. We put the range from and to. Here we'll have to put the number. Whatever number comes as x value, you have to put this number here. This is one difference. Here in this solution set, you don't put this number. See, we did not put plus 2 here in this series. But here you have to put 2. Now the question is, then how do we denote? How do we indicate that 2 should be excluded or included? How do we denote? That is why these brackets are there. These brackets help you in denoting if the number should be excluded or included. Now, this curved bracket denotes excludes. So if I put 2 here, it means that 2 is excluded. You can put the solution set in 3 methods, in 3 ways. One is using brackets, the other one is using number line, and third method is by plotting a graph. We have seen this first method by putting in brackets. Second thing is putting in number line. In number line, anyway, we put the numbers as it is. We will have to denote excludes here. Now, how do we denote excludes here? It's a empty circle. Empty circle denotes excludes. So it's 2. The value of x is 2 here. So above 2, just put an empty circle. Now let's take this example. Solve this particular expression when x is an integer and x is a real number. For real numbers, put a range. For integers, put series or sequence of numbers. Now let's take first case, x is an integer. So here we figure out that x is greater than -2. Now what is the solution set? First it is greater than, there is no equal to. That is a clue. When there is no equal to, that means exclude. -2 needs to be excluded because it's just greater than. There is no equal to. Greater than -2 is -1, 0, 1, 2, 3 on the right hand side of the number line, right? If this is the number line, greater than -2 is -1, 0, 0, 1, 2, 3, so on till infinity. So we'll put this entire series, -1, 0, 1, 2, 3. We'll not put -2 in this, right? And then how do we denote in the number line? Empty circle. This denotes that -2 is excluded. Now this is clear. Now, when you go to real number, how do you express? You express it as a range. Now here you'll have to put -2, greater than -2. So -2 to infinity, from 2, from -2 till infinity. Now what about the bracket notation? Exclude. This is exclude. This curved bracket is exclude. And infinity should always have an exclude symbol. Okay. Whenever there is infinity, it should always an exclude symbol. That is, it should have curved bracket. The reason we are putting these real numbers in a range is, for example, it can be, real numbers can be -2, -2.001, -2.02, -2.00003. Then you can write -1.01, then -1.02. See, this can go on like this. There is no end to these decimal numbers. There is no end. It's unlimited. So there is no point putting these numbers in the sequence. That's why we simply put the range. Any number between these, with how many our decimal numbers, or with fractions or rational or irrational, any number between this, you can put this in the solution set. That's why we simply put from and to. But when it comes to integers, it's very clear. You can't put decimal. No number in between 0 and 1. It has to be just whole numbers, 0, 1, 2, 3. That's why we can put this in this particular format. Now, this is a clue in case you get confused why real numbers should be in a range and why integers should be in the sequence. There is a reason. How will I put this? Right? Everybody can put their own numbers. You might put 2.001. Somebody else will put 1.01. There is no end. That's why, to generalize, we put this particular range. Let's take this example. This is having less than and equal to here. This is the difference between other previous problems. You have minus here, minus here. Minus here, minus here. Now we have negative sign here, negative sign here. We cannot leave it like this, right? We will have to eliminate this negative sign. So what we do, we multiply with minus on both the sides. You multiply minus on both the sides. So when I multiply, minus means I say -1, right? So when I multiply -1 with -x, it's going to become +x. -1 with -8 is going to become +8. Whenever you're multiplying with negative numbers, signs will reverse. So here it's less than or equal to, it will become greater than equal to. Now you just don't have to multiply every time. You just do it in your mind that whenever there are negative numbers, if I have to remove the negative number, then I have to simply reverse the sign. That's all. You just don't have to show this particular step of multiplying both the sides with the negative number. Now here, since we have equal to sign, the x value should be included. So how will your solution set look? First of all, it's a real number. First of all, check if it's real, x belongs to real number or x belongs to integer. Here it belongs to real number. So you have to put a range. It's greater than 8. Greater than 8 means 8, 9, 10 till infinity. So 8 till infinity, right? And 8 should be included because it's equal to sign. So what is the symbol for that? It's a shaded circle. This is includes. Now in the brackets, how do I represent? Square bracket is always include. And infinity should always be excluded. So that's why this is curved bracket. Always when you have an infinity, don't think, simply put curved bracket when there is infinity. So this is a solution set. So here you have another problem. X belongs to real number. So you just draw the number line. Let's get the solution first. So you get x greater than or equal to 1. Greater than or equal to 1 is 1 to infinity. Equal to is there. So it should be 1 should be included. And the symbol is shaded circle. And here you darken this portion of the number line so that it is very clear. Darken this, right? I have denoted in a different color so that it is clear that this is the portion of solution set. This is in the form of number line. Now if you have to write it in this format, right, you have to put the range 1 to plus infinity. 1 is included, so square brackets. Infinity should always be excluded, so curved bracket. Here similar problem, but x belongs to integer, and here it's greater than or equal to 1. X belongs to integer, so you have to write sequence and series. You have to put it in the form of sequence or series. So put all the numbers. X is equal to greater than 1, so 1 2 3 till infinity. Since equal to is there, 1 should also be included. In the number line you put shaded circle, 1 to infinity, right? Shade this portion, darken this part of the number line so that it is very clear. So here in this particular example, it's greater than 4. There is no equal to, so it's always excludes. Let's go through few statement problems. Basically, these are application of linear inequalities. Where do we apply this linear inequalities? Let's take this example. Ravi obtained 70 and 75 marks in first 2 unit tests. Find the minimum marks he should get in the third test to have an average of at least 60 marks. So he has scored 70 in his first unit test, 75 in his second unit test. How much should he score in the third test so that the average of the marks becomes 60 marks? So what we will do, let's assume, what is that we don't know? We don't know the marks of the third test. Whatever we don't know, we represent it as a variable. Whatever we don't know, we represent it as x. Now what is average formula? Average is first test marks plus second test marks plus third test marks by total test. This is the average formula, right? And it should be greater than or equal to 60. He wants at least 60. At least 60. That means, at least means 60 and above. Minimum he wants 60 and it can be above. So greater than or equal to 60. So you get an inequality here. So now you'll have to find the value of x. So x is greater than or equal to 35. So Ravi should score 35 or more than 35 in his third test. Now second problem, find all pairs of consecutive even integers which are greater than 5 and their sum must be less than 23. Consecutive even integers means 2, 4, 6, 8. Consecutive even integers. Now there is a condition. The numbers should be greater than 5. If I take two numbers 6 and 8. This is a pair of even integers. 6 is one number, 8 is one number. They are consecutive because after 6, the next immediate even integer is 8. Now, when I add these two numbers, when I add 6 plus 8, it should be less than 23. Now, we'll have to find all such pairs, right? It can be 6 and 8. It can be 8 and 10 also, right? 8 and 10, it's greater than 5. This number is greater than 5, right? And when I total, it is 18, which is less than 23. Then I can take 10 and 12. 10 and 12, 10 is greater than 5. And when I total, it will be 22, which is less than 23, right? These are the pairs. Now, how do we find these pairs? So what we will assume, we'll assume that x be one integer and x plus 2 be next consecutive even integer, right? If x is one number, then x plus 2 will be the second even number next to it. So when I add these two numbers, x and x plus 2, when I add these two numbers, say this is number 1 and this is number 2. You can assume that this is 6 and 8. When I add these two, it should be less than 23. So when I solve this, I will get x less than 10.5. Now, it's an integer. So what is the integer less than 10.5? Is it 10.4? No, because 10.4 is not an integer. So what is the integer below 10.5? Less than 10.5? It is 10. 10 is the integer. So solution set will be numbers less than or equal to 10, right? Less than or equal to 10, but greater than 5, because they've told it should be greater than 5. So between 5 and 10, between 5 and 10. So it should be greater than 5. So 5 is not included. 6, 7, 8, 9, 10. Don't make the mistake of telling less than 10, because it is less than 10.5 here. Less than 10.5 is 10, 9, 8, 7, 6. Now this is a solution set. We can form the pairs. You start from 6, next consecutive number is 8, and then 7 is an odd number. So eliminate that. 8, then 10, and then you take 10, and the next consecutive number is 12. Now 12 is not there in this range, but the condition is for the first number. First number, here we are telling x should be less than 10. What is x? X is first number. X is actually first number. X plus 2 is second number. So first number is 10 So second number can be 12. Here's another example. How many liters of water will need to be added to 1125 liters of 45% of solution of acid, so that resulting mixture will contain more than 25% but less than 30% of acid content? So you have a solution, you have a liquid, it has 1125 liters of liquid. In that 1125 liters, 45% of that liquid is having acid. 45% of this 1125 liters is acid. How many liters should I add? How many liters of water should I add so this entire acidic portion, right, reduces to 25% or 30%? It should be in this range, 25 to 30%. Now, what is that we don't know here? First, figure out what is that we don't know. We don't know how many liters of water. That means we'll have to assume that there are X liters of water. Now, in this 1125, we have 45% of 1125 is acid. And this should be less than 30% of the mixture. What does the mixture contain? 1125 and plus X, which is water. We are going to add X amount of water to this mixture. And when you add, the resulting mixture should have 30% of acid. And here, the original mixture is 45% of 1125. Now, you use this inequality, solve the value of X. Get the value of X. You'll get X less than 562.5. So, this is the amount of water that needs to be added if you have to get 30% acid. Now, it should have more than 25%. It should have more than 25%, less than 30%. We have solved the problem with less than 30%. Now we'll have to solve the problem with more than 25%. So same problem, will put more than, greater than 25% of the mixture. You'll get the value of X as something like this, 900 greater than X. Let me reverse this because I can't say 900 greater than X. I have to tell in terms of X. So I will reverse this. I will bring X this side and put 900 that side. When I'm shifting it like this, the signs will reverse. So here it was greater than, it will become less than. So X less than 900. So now what is the range? Range is when X is greater than 562 and less than 900 liters, I'll be able to get that required mixture with 25% to 30% acid. This is a straightforward problem. A solution is kept between these two temperatures. This is in Fahrenheit. You have to express in degrees, in Celsius. They've given the formula here, Fahrenheit to Celsius, right? Simply use this formula, substitute first 68, you'll get Celsius for 68, then find the Celsius for 77 separately. So you'll get two numbers, 20 degrees centigrade and 25 degrees centigrade. So range is 20 degrees centigrade to 25 degrees centigrade. Now, the second topic is about how do you denote the solution set in the graph? If there are expressions or linear inequalities given, how do we plot them in a graph, right? Here are sample graphs. This is how a solution set is represented. This line that you see here, these lines are called as boundary lines. They represent the equation that is given in the question, right? These are the equations. They're called as boundary line. Now again, this line can be a broken line or a solid line. If you have to represent includes, we'll have to put solid line. And if you have to represent excludes, you have to put a broken line like this. Now, you divide the entire graph into two parts. Let's take this particular line, right? This is some equation, right? I don't know what it is. I'm just putting a sample here. Let's assume that this is one equation, right? Or linear inequality. Now, so there are two regions here. One is above the line. The other one is below the line, right? This is one region. This is one region. I'll call this as region 1 and region 2. Above the line, below the line. At the same time, there is another region here. On the right hand side, there is one region. And on the left hand side, there is one region, right? Left hand side, one region. Right hand side, one region. Here, if I take this as the linear inequality or equation, on this side, there is one region. And on this side, the other side of the line, there is one region, right? And here, if you look at this particular case, here you have one region above the line. And below the line, there is one region. If you look at this particular line, left side there is one region, right side there is one region, right? Similarly for this line, left side and right side. These are called regions in this entire coordinate plane. Now based on the inequality, based on the values of x and y, we will find out if the solution is on the left side, right side, above or below the boundary line. Now let's take an example and go through step by step. First step is ignore the inequality sign, assume that there is equal. Then you assume that x is 0. If x is 0, then get the value of y. Y becomes minus 2. Next step is assume that y is 0. Now you'll get the value of x, right? So now you have 2 points. This is 1 point. X is 0, y is minus 2. X is 2, y is 0. Now you have 2 points here. Take both these points, plot it in the graph. 0 minus 2. X is 0 here, and y is minus 2. So here, minus 2. Plot it like this. Then second point is 2 and 0. X is 2 here, and y is 0. So this is yet another point. Now join these 2 points and you get a boundary line, right? Now, how do you know if it's a solid line or broken line? There is equal to sign here. So it's a solid line. If there is no equal to sign, then it will be a broken line. Simple. Now we have finished one step. We have plotted the graph also, right? Now next step is how do you find out which part is a solution set? Is it above the boundary line or below? Is it here or is it here? We need to figure out that. For that, what we have to do is we'll take some point 0, 0. That is, we'll take x is equal to 0, y is equal to 0, right? We'll substitute x as 0, y as 0 in the expression. Now we'll see if this particular inequality is satisfied. Now when I put x is 0, y is 0, I'll get 0 less than or equal to 2. 0 is less than 2. Condition is satisfied. 0 is less than 2. Since the condition is satisfied, what I will do, I'll put the solution set in such a way that this point 0, 0 is included. Because 0 satisfies this particular condition, this point needs to be included in the solution set. That means this is the 0, 0 point, right? This point is 0, 0. This needs to be included. Where is this? This is above the boundary line. 0, 0 is above the boundary line, correct? So start shading above the boundary line. So the solution set is here. This is the solution set above the boundary line, right? Let me just summarize the steps, right? First step is, if there is an inequality sign, put an equal sign and get the value of x. First put x is equal to 0, then put y is equal to 0. You will get 2 points. Now once you get those 2 points, plot it. Now second step is, you have to identify if you have to make the boundary line as broken line or solid line. If there is equal to, then solid line. If there is no equal to, then broken line. Step 3 is, you divide the region into 2 parts. One above the boundary line and one region below the boundary line. Now you take some point, say 0, 0. You take any point actually, but take some point 0, 0, x as 0, y as 0, and see if the inequality is satisfied. If it is satisfied, then your shaded region should include, your solution should include this particular point. If not, it's the opposite side, right? Like this. If the condition is satisfied, if 0, 0 is satisfied here, then the solution should be towards 0. Towards 0. That means here it's below the boundary line. Simple. Let's take this particular example. X plus y less than 5, right? So I'll first equate it to 5. I'll put x as 0. I'll get y value. Now we put y as 0, got x value. So I get 2 points here. Is it not? Right? This is 1 point. This is 1 point. Now I plot that point here. And now how do I figure out if it's solid line or broken line? It is less than here. Right? It is less than. There is no equal to. So it's a broken line. Simple. Now, step 3 is, I have to find where is the solution, right? What are the regions here? This is one region, this is one region. That is one below the boundary line, one above the boundary line. Where is the solution? Put x as 0, y as 0. You'll get 0 less than 5. Obviously, 0 is less than 5. Condition is satisfied. So, the solution should include 0, 0. Now, where is 0, 0 here? This is where 0, 0 is, right? This point is 0, 0. So, this point should be included. That means your solution is below the boundary line, because this point is below the boundary line in this region 1. Therefore, you shade this portion. You shade this region 1 like this. Here's another example. X greater than or equal to 3, y greater than or equal to 2. Here, how do you plot the graph? There is nothing that you have to substitute. Directly, they've given the value of x. Directly, they've given the value of y. You don't have to, figure out the points. On the x-axis, I draw a straight line at this point 3 and y is equal to 2. So go to y-axis, find a point where there is 2 and draw one horizontal line. Because equal to is there, it's a solid line. Now the last step is, you need to find the solution. Here there are 2 equations, right? So you have to find solution separately. Now first, let's take this equation. Let's take this equation, x is equal to 3. X is greater than or equal to 3. Let's take this equation. Put x as 0. So what will happen? 0 greater than 3. Is 0 greater than 3? False. This is false. So since it is false, 0 should not be included in the solution set. Now, this line is x is equal to 3. Now, this is one region, this is one region. One on the left hand side, one on the right hand side. Now, 0 should not be included. That means the solution is not on this side. It should be on the opposite side. So, this side is a solution, like this. So, you shade it like this, right? This entire yellow portion is the solution for this particular expression, x greater than or equal to 3. Same thing we'll have to do for this particular expression, y greater than or equal to 2. Here, again, you put y as 0. Is 0 greater than 2? False. So, again, it's away from this point 0. This is the second equation, right? Y is equal to 0. This is the equation. And this is 0, 0. This should not be included. So, what you will do, the solution is on the opposite side, not on this side, because this side you have 0. So, opposite side. So, this is the shading area. This is the shading area. Now, what is the final solution set? You need to find the overlapping region between this area and between this area. You need to find an overlapping region. What is overlapping region? This portion, right? This portion is overlapping like this. So, this forms the solution set. It's also called as feasible region. Let's take this particular example, right? Here you have two inequalities. Equate it, get the value of x and y. That is, first put x as 0, then put y as 0. So, you get these 2 points. Now, plot these 2 points. This is 2x plus y, this line. So, now, these are the points. This and these are the points. You have joined them. Extend the line. Now, you go to the second expression, 3x plus 4y. Put x is equal to 0. You get y value. Put y is equal to 0, you get x value. Now, you get 2 points, 0, 3 and 4, 0. That is, this is 1 point and this is 1 point. Join these 2 points and you get this line, right? This is that line. This is that boundary line. So, now you see there are 2 lines here. Now, how do I find the solution? So, now you put x is equal to 0, y is equal to 0 in both these expressions. So, when I take this first expression, put x is equal to 0, y is equal to 0, I get 0 greater than 6. That is false. 0 is not greater than 6. So, solution set is away from 0, 0. Where is 0, 0? This is where you have 0, 0. Solution set is away. Now, let's take the first equation. This is the first equation, right? This yellow one. This is towards, this side is towards 0, 0. This opposite side is away from this. So, since the condition is false, my shading is this side. Away from 0, 0. This is what I've done here. Shading like this. Take this entire boundary line, keep shading on the opposite side. Now, I'll go to the second equation and see if the condition is satisfied. You put x is 0, y is 0. 0 is less than 12. The condition is true here. In this case, condition is true. That means the boundary line, the shading should be towards 0, 0. Towards 0, 0. Now, this is the expression, right? For this equation, this is the boundary line. It should be towards 0, 0. This is 0, 0. Towards this. Towards means you should shade it like this, inwards. Shade it towards 0, 0. Now, I have 2 areas here. This is one shaded region. This is one shaded region. Now, I need to find a solution set. For that, I need to find a common region where both the shading overlaps. That region is the final solution set. Now, that region is nothing but you find the intersecting point between these 2 lines. What is the intersecting point between these 2 lines? This is the intersecting point, right? Between these 2 lines is the common overlapping region. Shade it, simple. Between these 2 lines and from where it is intersecting, this is the joining point, intersecting point, shade the region. This is the solution set or feasible region. Now, this is one example where there are 3 inequalities given. This one, this one, this one, and then you have these 2 also. So, basically 5 inequalities are given in this one particular problem. How do we solve that? First thing, when x is greater than 0, y greater than 0, which quadrant it is? This is my graph. X is greater than 0, y is greater than 0. Means it is first quadrant. First quadrant. This is first quadrant, second quadrant. This is third quadrant and this is fourth quadrant. This is x-axis, this is y-axis. Here the x is positive, right? All the x values are positive. Here x values are negative. Here y values are positive. Here y values are negative, right? Now, x is greater than 0 means positive. Y greater than 0 means it's positive. Which quadrant both x and y are positive? X and y both are positive here in this particular region. That is in the first quadrant. So, this is a clue that whatever solution you are finding should be in this region. This region should have the overlapping region. Now, let's look at the other expressions. We know where is the shaded region or solution set for this. It's a first quadrant. first quadrant. Now we will do the same 3 steps for each of these expressions. So here, when I put x is 0, y is 0, I'll get 0, 5 and 10, 0. Now I need to find the region. Is it below boundary line or above boundary line? So here when I put x as 0 and y as 0, last step, I'll get 0 less than or equal to 10. 0 is less than 10, so condition is true. Therefore, the 0, 0 should be in the solution set. So the region, the shading should be towards 0, 0. This is the boundary line or equation for the first one, x plus 2y is equal to 10. Right? Now, where should the shading be? Towards 0, 0. Because the condition is satisfied. So shading should be here. This portion, the shading will be, correct? Towards 0, 0, here, till here. Now let's go to second expression. X plus y greater than or equal to 1. Right? We get the points, we plot it. Right? The points will be like this. The points will be here. Here, these are the points. This is that second line. Right? Now, where should the shading be? When I put x is equal to 0 and y is equal to 0 here, it will become 0 is greater than 1. False. 0 is not greater than 1. So it is false. That means away from 0, 0. Away from 0, 0. Above the boundary line. So 0, 0. The 0, 0 is not part of the solution. It should be away. This is the line. This is the line. Above this line is the region. This is the region for this second equation. Now there is another expression. X minus y less than or equal to 0. So here it's slightly tricky. If I put x as 0, I'll get y as 0. If I put y as 0, I'll get x as 0. Now how do I draw this line? This is the point which has 0, 0. So just take a line and just draw a line at this particular point and stretch it. This is that line where x minus y is equal to 0. Now how do I find the region? Is it above this line or below this line? Slightly tricky. I can't put 0 here. If I put 0, it will become 0 minus 0 less than or equal to 0. Obviously 0 is equal to 0. So what I will do, since it's tricky, what I will do, I'll take one point here above this boundary line and take one point below this boundary line and see which point will satisfy this condition. So let's take one point, say, we'll take this point, this extreme point we'll take. That is y is equal to 5 and x is equal to some value we'll take, say x is equal to 2. Now we'll find out, right? So what will happen when I do this? So it will be 2 minus 5 is less than or equal to 0. Minus 3 less than or equal to 0. This is true. That means this point 2, 5, x is 2 here, y is 5 here. 2, 5 means the point is here somewhere. This is the point, right? So this particular region is true. That means this point should be included in the solutioning. Now let me find the second one. Let me also go to the other end. This is the other point. This point. Here y is 0 and x is 10. So when I do that, I'll get 10 minus 0 less than or equal to 0. Is 10 less than or equal to 0? This is false. Which means that this point is not part of the solution. That means there is this region. This region is not part of the solution. That means above the boundary line. So this becomes the region. Now what is the common region? This is a common region. Look at all the intersecting points. This is the common region. This is a solution set or feasible region. With this, we've come to the end of this particular topic. If you've liked this video, do press a like and share it. Thank you.